Okay, so now we need to uh, add some animation modifiers to our animations. So for that, first let's open the idle to jog forward animation. So here's idle to jog forward animation. So I'm gonna remove the existing modifier. We'll start from scratch. Okay, so I'll idle to jog forward. First we need to add sync markers. So in order to add the sync marker, so you need, if you open the add modifier, and there we have the sync marker and the modifier, right? So before, so if one of the notifiers not showing you properly, just go to plugins and make sure that all the animation related plugin, let me go to animation, locomotion library, animation modifier library, these plugins, and animation warping, these plugins are available. So I'm gonna select the sync marker and the modifier. So I'm gonna, against the bone, I'm gonna use the foot underscore L, not ball, foot underscore R, and for the name I'm gonna use left and right, apply modifier. So now we have the modifiers, foot sync modifiers, foot sync markers, sorry, already. And next we need a speed of the animation, at which speed the root bone is moving. So if I uncheck the enable root motion and force root lock, you can notice that these animations are properly root motion based animations. So if I uncheck that, you can see our root bone is moving with the character. See? So we need to find out what velocity, what speed this root is moving. So I'm gonna tick the enable root motion again and force root lock, and I'm gonna use the motion extract modifier. So we need to use the bone name root. Translation, we need to use get the translation speed. Alright, and translation speed in every direction, maybe XYZ. Okay, translation speed. And next we need to use custom name. I'm gonna call it to moving speed. Right click and apply modifier. So there we have the animation moving speed is ready. Let me just go through my notes real quick. Alright, it's fine now. So we have moving speed, and next we need a rotation curve. So in order to do the rotation curve, let's grab the idle to jog 90 animation. I'm gonna remove all the modifiers. So if I uncheck the root motion, you can notice that our root bone or character is rotating towards left and then start moving. See? So we need to get this information and map that information into the curve. So in order to do that, I'm gonna use the animation modifier, motion extract modifier. Bone name is root, and we need to use the rotation, not rotation speed, and we need to use it into z-axis. We need to get the information against z-axis, and I'm gonna use custom curve I'm gonna call it to rotation curve. So this will map our rotation into 0 to 1. Sorry, this is 0 to minus 90. I'm gonna remove the curve and set it to normalize, and now again apply modifier. There we go. So now you can see the rotation is applied in form of 0 to 1 curve. So we need to apply these modifier to all the animations we have. So I'm gonna real quick in order to get this, I'm gonna select all the animations, either to jog forward 90, 180, 90 right and 180 right, and I'm gonna also select either to walk, all the animations, walk forward, jog forward. So we have selected all the start animations and looped animations. I'm gonna right click and add modifiers. So first we need to add sync marker modifier and set the properties to foot underscore L and foot underscore R. Okay. And the next modifier would be motion extract modifier, which will be our speed, at which speed our root is moving. So we use the translation speed in all XYZ axis and map it into the curve. I'm gonna call the curve a moving speed, and one more variable to extract the rotation data, motion extract modifier, and rotation modifier, motion type rotation axis is Z, normalized to true, and custom curve name is to rotation curve. There we go. So we have these three animation modifiers ready. I'm going to apply it to all the animations. Come on. There we go. So we have all the modifiers ready. So let's check one by one. We have sync markers, we have rotation curve 0 to 1 and moving speed. Fine. Sync markers, moving speed, and rotation curve. Remove this existing rotation curve. Sync markers, moving speed and rotation curve. Fine. Sync marker, moving speed, rotation curve, and moving speed. So in our jog forward, our moving speed is 450. I'm gonna set a constant variable. I'm gonna call it to 450. So this is our constant speed for 450. And for the rotation curve, I'm gonna set it to first variable key to 0, and after 3.35 seconds goes to 1. I'm gonna set the keys type to automatic tangent. So now we have all the rotation curve also mapped from forward animation. Sorry, not forward. So for jog forward animation we don't need rotation curve. From either to jog anyway forward we need rotation curve. So for that I'll set it to 1 and 0. Set it to point. After 0.35 seconds our character should properly rotate towards the desired direction. So let's again check idle to jog forward. Moving speed is fine. I'm gonna remove the curve from here, and rotation curve is also mapped correctly 0 to 1. Okay. There we go. So we have now all the animations are ready, which we can now use to rotate our character and move towards the desired direction. So now we have all the animations are ready, and I'm gonna go to my animation blueprint. So now we need to create a function which will update our character rotation based upon our animations. So I'm gonna right click into the event graph and search for event update event blueprint event post. So we have blueprint post evaluation animation. So this function fires after this function, after the animation tick, this post evaluation animation function fires all the time. So we'll use this event, this function, sorry, and create a new function. I'm gonna call it update character rotation. Go to the event graph, add the function over here to the post evaluation blueprint. Double click on the update character rotation and check for if our locomotion state equals to idle. Locomotion state is equal to idle, then we currently don't need to do anything, and in future we'll perform the turn in place functionality. So if our turn character is in idle state, if it is not in idle state, then we need to update rotation, update the character rotation. For that, I'm gonna create a new function, update rotation while moving. There we go. So here I'm gonna connect this function over here, update rotation while moving. And in our update rotation while moving, so first we need to get our primary rotation, which we have created on enter, run enter animation, and now we need to get our input vector. Rotation from x vector, make rotation from x, and I'm gonna set it to enter to constant. Current target delta time is our delta time x, and speed is gonna be 1000 for this. And for secondary rotation, I'm gonna also use enter to, and the target will be our primary target rotation. Delta time will be our delta time, and the rotation speed, inter speed of our for now 8. So these are our primary or secondary variables are set up. So we'll get the input vector and then make the rotation from x vector. So in which direction our input vector is, we'll rotate our character towards that direction. So we set the secondary variable over here so that we can perform it smoothly, interpolate it from primary to secondary. Proper interpolation should be happened. and then after that I'm gonna get my access, drag it pawn owner and set actor rotation. There we go. And for our actor rotation, I'm gonna use make rotation from X. Sorry, I need to use make rotator, just that's it. And so remember, we have the all the curves mapped into 0 to 1. So let's say we need to move towards left, so we have this information 0 to 1 and our locomotion start angle is 90. So we'll use this rotation curve 0 to 1 curve and multiply that curve into our locomotion start angle, which means we can then rotate our character smoothly towards that directions. So let me add it into here. I'm gonna get curve value. The curve is rotation curve. I'm gonna copy the name, paste it over here. So here 0 to 1, I'm gonna map it. So we have it 0 to 1, I'm gonna map it to 1 to 0, 1 to 0, and then multiply it with -1 towards the opposite direction, and then multiply the result towards our locomotion start angle. So we have this locomotion start angle. There we go, and set it over here. If I play now, you can see there's a jitter because we need to get our secondary rotation first. Split and plus it, add the result into our secondary and then add it over here. So first we have set up the input vector and set the rotation into our secondary rotation, and then we grab the secondary rotation yaw and add our curve value multiplied with start angle towards the into the yaw, and then set our actor rotation. See, our character is now properly turned towards the desired direction, and then start running. How cool is it? There we go. So now we have our upgrade character rotation is ready. So you'll notice when we enter into cycle state, our character just flips its rotation because our rotation curve is 0 at that time. Let me print string and show it to you guys. So you can notice it goes to 0 to 1, and then when we are in cycle state it goes to 0. So that's why our rotation, our character snaps into the wrong rotation. So in order to fix that, real quick, we need to go to the base locomotion. So here is our cycle state machine. Open the cycle state, and when we are in cycle state, just modify the curve. Whichever animation we are playing, if we are in cycle state, just modify the curve, which is rotation curve, and set it to 1. That's it. And now if I hit play, see, our character perform proper start animation and then start running it towards that direction. And it will also works if we change the direction. You can see it properly follows towards the input direction. So now we have start animations already, and next we need to use, so we have added the sync markers, but we also need to set the sync groups over here. So I'm gonna group name it to locomotion, and I'm gonna set it to sync group. Now I'm gonna copy the name, go toward the start animation, set the name, sync group. So here we have sync groups ready. So we should have sync group applied on all start and cycle animations. So start animations, we have applied the sync group, and cycle we have also applied the sync group. With this way our animation blends properly. See, it now properly blends towards the cycle state. So this functionality works pretty fine now. And you can notice that our feeds are currently sliding when we are performing the turn start animations. So next we'll fix this slide issue with our play date, and after that we'll add these stopping animations.